So for the next series of questions, we're related to the problem that they gave us at the beginning, the prompt at the beginning, that says the equation h of t equals negative 16t squared plus 64t plus 32 represents the height in feet of a water balloon t seconds after it was launched from a mechanical device. So we have a projectile motion question here. It's quadratic because a projectile motion question is in the shape of a parabola. And so we have something that's quadratic. There are parts to this equation that we know because we know projectile motion questions, we're used to them. And so we know that this right here, 32, that's my constant, that has to be my starting point. Because if time was 0, this wouldn't be here, because 64 times 0 is 0. Time was 0, this wouldn't be here, because 0 squared times anything is still 0. So at the beginning, when time is 0, the only thing that would be here would be the 32, which means this is my starting point. I start at 32 feet, which means this thing is launched from already being up in a position. So maybe it's launched from a cannon or something, right? Okay, so this is my initial height. Because when t is 0, that's the only number that's going to be there. So at time 0, that's where I start, my initial height. This number in here tells me how much I travel, right, in feet per second, right? So this is the speed at which that ball or that balloon is launched from whatever device it was launched from, cannon or whatever. So this is my initial speed. So I'm going to say initial velocity. That's my initial speed. I'm going to put that there. This right here tells me how much is being pulled down on it, right? Because anything I shoot in the air comes down, and the reason it's coming down is because of my gravity. So this is my effect of gravity. Effect of gravity. So, a projectile motion question, it's quadratic because it's going to be a parabola. The square term is going to be negative because that's my pull of gravity pulling it down. This is the speed per second that it initially took off at. So that's the speed that it initially was shot out at, right? Before gravity starts pulling on it. And this is the height that I started at. So when we know those components, we can begin answering the questions about it. The first question says, from what height was the balloon launched? Well, we just talked about that. When time is 0, this goes away. So this has to be my initial height. So I was launched at I was launched at 32 feet. So the cannon was probably 32 feet in the air first. The next question says, what does the term 64t represent in this equation? Well, we talked about that too. That's my initial velocity. That's my initial velocity. So then I get to questions that start asking me to do some math. What is the maximum height of the water balloon? So we know the maximum height of a water balloon, well, if it's a parabola, it's going to be going up and down, right? The maximum height is going to happen here, but that's going to be in the middle of my parabola, right? That's going to be very in the middle of my parabola. We call that line the axis of symmetry. We call it the axis of symmetry because it's the line that folds the parabola in half. It's the middle line that divides into a symmetrical, one side and symmetrical on the other side, the axis of symmetry. That's where my maximum is going to occur. My maximum is going to occur in the middle of a parabola, which means it happens at the axis of symmetry. Well, we were taught the quadratic formula. And the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Well, that's two different parts to that formula. There's this part right here, right? that has a function to tell me how many solutions I have, right? We call that the discriminant. And then there's this part right here, right? The part that is added and subtracted from, excuse me, the part that I add or subtract to let me know what my solutions are. So this would be where my middle is. So this part of the quadratic formula, this part right here, is called the axis of symmetry. So the axis of symmetry has a formula. It is x equals negative b over 2a. Right? So whenever you're looking at the quadratic formula, this piece tells me how many solutions I have, right? Depending on whether or not it's positive, negative, 0. It tells me whether or not I have solutions. We call that the discriminant. But this part tells me where my middle is, the axis of symmetry. So the formula for the axis of symmetry is x equals negative b over 2a, right? We're going to use that to solve this question. So what is the maximum height of the water balloon? We're going to use our axis of symmetry to get us the middle, because the maximum will be at the middle. I'm going to change x to t because that's the variable we're using. So instead of x equals, we're going to have time. T equals negative b over 2a. And we're going to plug in. So negative b, well, standard form, ax squared plus bx plus c, right? So that means this is a, this is b, and this is c. So b is 64. So negative b would be negative 64 divided by 2 times a. A is negative 16. That's negative 64 divided by negative 32, which is positive 2. So at t equals 2 is where the maximum happens. But remember, t is time. So that means this happens at 2 seconds. That doesn't tell me what the maximum is. It actually answers this question. At what time does the water balloon reach the maximum height? This is the question that answers time. So I reach the maximum height here at 2 seconds. 2 seconds is the answer to this question. Let's go back to this one though. What is the maximum height? Well, if I know what happens at 2 seconds, to get the height, since this is a height equation, I'm going to find the height given that the t is 2 seconds. So I'm going to find the height of t at 2 seconds. And everywhere I see a t, I'm going to make it 2 seconds. Negative 16 times 2 squared plus 112 times 2. Excuse me, 112. That's a problem from a previous lesson. 64, I believe it was. Yeah, 64 plus 32. That was the equation. Yeah? Okay. So I plug this into my calculator. I mean, I can do it in my head, but we've got our trusty calculator here, so let's make this move a little faster. Negative 16, parentheses, 2, parentheses, squared, plus 64, parentheses, 2, parentheses, make sure you put your parentheses in, plus 32. We've got 96. So 96 feet is where my axis of symmetry happens, which was the height of the maximum height of the water balloon. Okay, so we've answered 4 of my 5 questions. The last question, how long will it take for the water balloon to hit the ground? Well, whenever I say something is going to hit the ground, that's me telling you what the height is going to be. The ground is where the height would be at 0, right? So I'm basically telling you that my height is 0. What that means is my equation now says 0 equals negative 16 t squared plus 64t plus 32. So I'm telling you that this equation, height is 0, So I want to know at what time. How long means at what time. At what time will this equation equal 0? At what time will the height of the water balloon be 0? So in order to solve this equation, it's quadratic. The numbers are really big, so I don't want to try to factor it. I don't want to try to complete the square. I'm going to use the quadratic formula. I'm going to use this entire formula, not just the axis of symmetry part. I'm going to use the whole thing, okay? So let's erase this circle and put the formula back the way we know it's supposed to be. Negative b plus or minus square root of b squared minus 4ac over 2a. And we're going to use the whole formula. We're not solving for x, though, because our variable this time is time. And so let's solve it. I have t equals negative b, well, b is 64, so I say negative 64, plus or minus the square root of, this is 64, that's b again, square that, minus 4 times, it says a times c, always substitute in parentheses. A is negative 16, c is 32, and all of that is divided by 2 times whatever a was, which is negative 16. All right, so this is going to equal negative 64 plus or minus the square root of, what is that? Again, let's use our machine. Let's type it in exactly the way we see it. So parentheses 64, parentheses squared, minus 4, parentheses, negative 16, parentheses, another set of parentheses, 32, close parentheses, enter, 6,144. 6,144. Make sure we typed everything in correctly. Okay, there's our answer. Over 2 times negative 16. Excuse me, we know that. We can just put the real answer there, we know that. 2 times negative 16 is negative 32. All right. Is that a perfect square? Let's square root it to see. Is it a perfect square? No, it is not. And so since it is not a perfect square, right? Normally I can leave my answer in radical form, but this is a real world question. And since it's a real world question, we're going to estimate to give us a real world answer. So as a plus and a minus, let's deal with both. So we've got negative 64 plus the square root of 6,144 divided by negative 32. We're going to get the plus answer first, and then we'll get the minus answer later. So this is going to be an approximation. Let's see what we have. Negative 64 plus square root of 6,144. Let's see what that equals. We get like 14 point something. We're going to divide that by negative 32. And we get negative 0.449. Okay? Oh, we get another answer because I don't like that answer. I'll tell you why in a second. First, let's try the other one. We have a minus, so let's do the other one. Negative 64 minus, we have the plus and the minus. Plus or minus means there's two different problems. So negative 64 minus 6,144 divided by negative 32. And let's see what that answer gives us. We have negative 64 minus this time square root of 6,144 equals, we get like negative 142 something, then we divide that by negative 32, and we get 4 0.449. Of these two answers, this answer will not work. Why? Because we're solving for time, and time can't be negative. So since time can't be negative, in our problem, I can't have negative time as a solution. So my solution is 4.449 seconds is when it hits the ground. And there's our answer.